Hello, I'm Headley Appley, and in this short video we'll take a look at the new features in Integrity Modeler 9.2. We'll start by looking at the new contemporary user interface, followed by improvements to diagramming productivity. Then we'll take a look at the OSLC integration with Windchill, the OSLC integration with Integrity Lifecycle Manager, static model analysis, and then improvements to installation and deployment. So let's kick off with the contemporary user interface, which now includes Microsoft Office-style ribbon toolbars, modern large icons, task-oriented tabs, user-configurable toolbar, icons on context menus, and a new welcome page. This makes it much easier to navigate the toolbars and find the functions you need. The user interface is more appealing and familiar, making it much easier to learn and get started. Here are some examples of the new Microsoft Office-style ribbon toolbars, and we'll take a look at them in action in a moment. The tabs include the Home tab for the most frequently used modeling functions and the Manage tab for all the model management functions. There are also task and diagram specific toolbars. Integrity Modeler 9.2 now also provides a configurable quick access toolbar and also icons on the context menus to make it easier to find the functions you need. And then finally, the welcome page, which gives you quick links to common actions, information on the latest new features and the Getting Started guide, and links to the most recent models. So let's take a look at all of this in action. So let's start by opening Integrity Modeler 9.2. Immediately we can see the welcome page with the quick links and guidance for new and infrequent users, and the ribbon toolbars at the top. Firstly, this is the Home tab, then we have the Manage tab for the model management capabilities, Tools, Find, and you can see here all the new large icons, and then tabs for simulation and all of the view options. We also have a tab for help. The context menus now all have icons. And we can see that new icons in the browser pane as well. As we move through the different diagram types, we then get new ribbon toolbars for each of those diagrams. Which group the capabilities that are only available on each diagram type. You can also see now that we have the quick access toolbar, as you find in most Microsoft tools, which is fully user configurable. And you can position it above the ribbon or below the ribbon. So as you can see, a contemporary, up-to-date user interface which is familiar, easier to navigate, and much easier to use, bringing it bang up to date. So now let's move on and look at diagramming productivity. Firstly, we've made lots of improvements to the diagram view options, making them more consistent across all types of diagrams and increasing efficiency when creating diagrams. We've also improved the profile diagram star settings, which is now integrated with the view options, making it simpler and more logical. And we've improved pasting options and stars to include compartments, also making it more consistent and improving productivity. Diagram templates can now be created for any type of diagram, and you can now drag and drop symbols from profile diagrams onto non-profile diagrams. So let's take a look at this in action. So I'll start off by looking at the new star setting environment. You can see it's significantly simplified. We can see everything in one place, setting things like background color, font, etc. We can also set the existing symbols to the default options so that changes can be applied to all existing items. You'll see we've updated an existing diagram, but we're also using it now when creating items on diagrams. We can reuse options and styles by stereotyping the diagram as a template. And when we create a new diagram, we can then select from the templates to set the style. So again, some dramatic improvements to style setting in Integrity Modeler 9.2. Now let's move on and take a look at the new OSLC integration with Windchill. The primary problem that we're solving here is that when you select your best-of-breed toolchain, you'll probably end up with a number of siloed databases. And the key is that you need to link them together. There are lots of reasons why you need these links. One first example is that you want to prove that your system design meets the requirements, and maybe those requirements are stored outside Integrity Modeler, maybe in a tool like Integrity Lifecycle Manager. And secondly, you want to check that your parts in your PLM system satisfy your system design, so you link to tools like Windchill. As well as using it during the engineering process, we also then need it for certification to prove that we're building the right systems and implementing them in line with certification standards. To make these links possible, we use an industry standards-based approach called OSLC, Open Services for Lifecycle Collaboration. This then allows us to link and trace to items in other tools. They could be requirements or test cases in Integrity Lifecycle Manager, or other tools like Doors Next Generation from IBM. And also, as we're going to see in this case, linking to parts in our PLM system. And in this example, we're using Windchill. The OSLC integration between Integrity Modeler and Windchill ensures that design dependencies between systems and software engineering and PLM are defined and managed. It also enables digital product traceability and impact analysis between system software engineering and PLM, and provides visibility of design changes with suspecting applied across those link traces. So now, within Integrity Modeler 9.2, the OSLC integration with Windchill means that firstly you can see parts from Windchill in Integrity Modeler. You can see that here on the right hand side. You can run a search to filter the number of parts that you see, and then based on the parts that you've selected, you can then create the links by dragging and dropping onto diagrams. Those links, you can then view the properties of the remote items using local information and a preview user interface. In the Integrity Modeler browser, you can see the version independent parts, so you can always point to the latest version, or you can see the version specific parts, so you can see here in this tree view, so that you can always point to a specific chosen version. So let's take a look at Integrity Modeler 9.2's OSLC integration with Windchill in action. So here on the right hand side we can see the OSLC navigator. We can run a query against the data in Windchill to filter and limit the number of parts that we see. Opening the query then lists the parts, and here we can see all of the parts returned. Selecting a part and drilling down, we can then see the versions of those parts. So as we said a moment ago, you can link to a version independent part or a version specific part. You can see all this information from Windchill without leaving Integrity Modeler. To create a link, all we do is drag and drop the part or the part version either onto a diagram item to create a direct link or into space to create a surrogate. In this case, we're dragging it onto a use case and then creating the link type of reference. We now see that we've got an OSLC link, and you can see the properties down there in the Integrity Modeler property area. In this example, we're now creating a link to a specific version of a windshield part. Then we can navigate to find those links. So from this use case, we can find the associated windshield part and open the property page. And this information is provided directly by Windchill and not stored in Integrity Modeler. So we're linking, not syncing. We can also navigate directly to Windchill, and given the right login credentials, we can go and see the part there. So we've got fully connected linking and tracing between any Integrity Modeler item and Windchill parts. Next, we'll move on and look at the improvements to the OSLC integration between Integrity Modeler 9.2 and Integrity Lifecycle Manager. Integrity Modeler 9.2 can now not only link with the live items in Integrity Lifecycle Manager, but also versioned and branched items. In this example, we're showing linking to versioned and branch requirements. Of course, it could be other item types in Integrity Lifecycle Manager depending on the mapping. So as we can see in this example, we can now show the version requirements and version documents with their version identifiers, and also branch requirements and branch requirements documents show the identifier of their source items. So now that we looked at the two fantastic new OSLC integrations between Integrity Modeler and Windchill and Integrity Lifecycle Manager, we'll move on to take a look at static model analysis. We provide static analysis in Integrity Modeler 9.2 through a second integration with Phoenix Integration's Model Center. This allows you to design constraints and parameterize requirements in Integrity Modeler and then use Model Center to take those as inputs, perform mathematical calculations, and then return results to the model. And this can indicate whether requirements pass or fail. This really helps you find problems much earlier in the design process and also increases the value of MBSE by enabling analysis and simulation throughout the whole design lifecycle. It really gives you trade study analysis at the systems level. The integration uses SysML parametrics to define equations, then constraint properties to define the calculations to be performed by Model Center, and requirements can be linked to simulation for verification of model behavior. So we can check that our system designs satisfy the requirements. We then run the calculation in Model Center MBSE, and the results are calculated and compared against the initial values. We can then tell if the requirements are satisfied or not, and then maybe go back and change the design and rerun to give different calculations on different options to provide a trade-off analysis. So let's take a look at that in action. So I start off with some parameterized requirements for a car braking system. And here we can see one requirement example is the brake pad life, which is set to have a life of a minimum of 36,000 miles. And at the moment we can see that we don't know if any of these requirements are satisfied by our design. In our system model, we've also designed the structure of our system and also the parametrics of our system. As I said, this is an example of a braking system, and here we can see things like the stopping distance, the torque, the surface area, the cost, etc. of our braking pad in our braking system. So now we can use the integration with Model Center to calculate the life and the cost of those brake pads. You can see that it's imported the system structure from Integrity Modeler. And also the predefined values and the placeholders for calculations. You can also see that the requirements have been imported from Integrity Modeler as well. Now, when we run the static simulation, Model Center will calculate those values for us. You can see it's now added them in. So we have the brake pad heat, the effective radius, the life and cost now calculated. And we can also see further down the page that the requirements have now all been satisfied. And if we save in Model Center and then refresh in Integrity Model, we'll get that latest data updated. So now if we move back to Integrity Modeler, you can see the values for the cost, the center length, effective radius, the heat, have now all been updated in Integrity Modeler. And if we took a look at the requirements document, we can see that the requirements are now also all satisfied. So let's make a change. We have a business need, a customer need to change the life of the brake pad. And we now want them to last for 72,000 miles rather than 36,000 miles. We haven't changed our design at this stage, we've only changed the requirement. So by rerunning the static simulation, we can see that the requirement for brake pad life is no longer satisfied. Here in Model Center, and then also back in Integrity Modeler. So you can now see that the requirement for brake pad life is not satisfied. To satisfy this new requirement, we then need to change the design. And in this case, we need to make the brake pad thicker. So we can now use Fingers Integration's Model Center to find the optimal brake pad thickness to satisfy that life requirement. So using the optimization tool inside Model Center, we can set the objective for the calculation as the life of the pad and the variable as the thickness. This is a trade study or parametric solving, and we select the appropriate Model Center algorithm and then run the calculation. This finds the optimal brake pad thickness, and the results are shown here in Phoenix Integration's Model Center. We can now take those values and apply them back into Integrity Modeler. So our design has been optimized to satisfy the new requirement for brake pad life. So just to prove that, we can now rerun the static simulation. You'll see here in Model Center that the pad thickness requirement is satisfied, as is the pad life. And now the brake pad life, if we do a quick refresh, is satisfied in Integrity Modeler. So that's the full circle background. So we've started with parameterized requirements. We've run a static analysis to check whether they're satisfied. We've changed the requirement, which meant the design no longer satisfied the requirement. So we updated the design, optimized it with Model Center, and then updated the model and rechecked the requirements are satisfied. So I'm sure that you'll agree that those new static model analysis capabilities will make dramatic improvements to your systems engineering productivity. Now let's move on and look at the last topic of installation and deployment improvements. Firstly, we've made installation and deployment a lot more flexible, so you can now choose a different location for your modeler AT files directory, so it doesn't need to be on the same server as your database. We've also provided a lot of performance improvements for things like model creation, model deletion, package clone, package import, updating of profiles, reconcile, rebase, and population. So that's covered all the main topics in this Integrity Modeler 9.2 What's New presentation. We've looked at the contemporary new user interface with that getting started page and the new ribbons and style and user interface. We've looked at diagramming productivity, particularly around style setting and style templates. We looked at the OSLC integrations from Integrity Modeler to Windchill and from Integrity Modeler to Integrity Lifecycle Manager, giving us really powerful integration across the whole tool chain, linking from systems engineering up to requirements, down to PLM parts and testing, for example. We've looked at the new static model analysis, which is in addition to the co-simulation, the visual co-simulation provided in previous releases, using that new integration with Phoenix Integration's Model Center, and also more flexible installation and deployment. So I'm sure you agree this is a wonderful release with some dramatic new features to significantly improve your productivity for model-based systems engineering.